Everyone, this is 4.6. We're using givens, properties, and definitions. So really just doing what we have been doing, except making sure that we're able to put everything together. So first example looks like this. And for all examples, we're doing the same thing. We're going to use the givens and any of the properties and or definitions that we've learned to mark the triangle. So again, take a minute to make sure that this is written in your notes nice and neat, so that you can refer back to it. So in example 1, we are given that AB is congruent to FD. So side AB and side FD are congruent. So what we want to do is just mark those on the diagram. So I'm going to find AB, which is right here. I'm going to find FD, which is right here, and we're going to mark those as congruent. So I'm just going to use one tick mark. Now, there are some arrows on those segments already, but remember those arrows mean they mean parallel. Those two segments are parallel to each other, but nothing about congruent. So we need to make sure we add that congruent sign. Okay. Now we're going to look to find if there's anything else that we can add to this diagram. The first thing I notice is that we have vertical angles, so we can mark those as congruent. And then the last thing, and I already pointed it out, but we have those parallel lines. So if we see parallel lines, we should check to see if we have any alternate interior angles. So we should see if we can make any letter Z's. So there I can see a Z. So now I know that this angle here, that angle A, and this angle up here, this angle F, they're congruent. And there's actually one more. If we can go in the other direction as well. So if we go from F to D out to B and back down, you can see that we've created another letter Z. So these angles are also congruent. Angle B and angle D. We could have also used the third angle theorem there as well to get that one. But yeah, I think that's all we can do. So 3 angles and one side congruent there. So we can move along to the next example. In example 2, again, pause, make sure that you get this drawn in your notebook. But in example 2, we're given that segment EK is a perpendicular bisector of segment AR. And I don't know that we've really used that all together, but a perpendicular bisector is exactly what it sounds like, okay? It's not only perpendicular, so here's EK and here's AR. So not only do we create 2 right angles, but it's also a bisector. Remember, bisector means cuts in half. Okay, so that segment right here also cuts segment AR into 2 congruent parts. So perpendicular bisectors do 2 things. They create 2 congruent right angles. They also cut that bottom segment in half, so we can mark that. Okay, and then the third thing that we can mark is we have this reflexive property. We have this shared side. The triangle on the left and the triangle on the right share side EK, so we can mark that as congruent. Okay, and I don't think that there's anything else that we can add there. There's nothing about an angle bisector anywhere, so we're not going to assume anything. We're not going to assume that AEK is congruent to REK. Nothing tells us that. All right, and then example 3, this time it says that M is the midpoint of AR. Actually, we kind of have a mistake there. Let's change that into an M instead of a K. M is the midpoint of segment AR. So all that tells us is that this point right here cuts AR in half, okay? Do not assume that these are right angles, okay? There's nothing that says anything about perpendicular, so do not assume perpendicular, okay? You are only allowed to say that something is perpendicular if it tells you it's perpendicular. It doesn't say that here, so we're not going to assume that. Only one other thing I think we could add, once again, we can use the reflexive property and we can mark EM congruent to EM. All right, and that is it. So go ahead and get started on your practice for 4.6.